Now we are going to have a look at adding complex numbers. So our complex numbers have the real part, which we often label A, and the imaginary part, which is the stuff involving I, which the coefficient of we often call B. And I is going to be the square root of -1. For our purposes, for just adding, I just acts like an X would, or A would, or any variable or any letter that we'd normally have in algebra. It's when we come to multiply that I will play a more active role. But for right now, it behaves pretty much exactly like any letter. So if we had stuff that was just numbers and stuff that had X's in it, we'd add our like terms. And that's really all we're going to do here. We're going to gather up our real parts, our number parts, our constants, and then we're going to gather together our imaginary parts, and we'll add the real parts together, and then we'll add the imaginary parts together. And that's all we have to do. So let's put this into practice. Often complex numbers, because they come in two parts, if you're putting in a complex number into a question, you put brackets around the whole thing. So we can see this notation in our exams. So what we've got here is our first complex number is the number 7 minus 5i. All of that is the first number, and we're adding 8 plus 4i. And all of that is the second number. So what do? We gather together the real parts. Our real parts are our 7 here and our 8 here. And our imaginary parts are minus 5i and our 4i. And we gather them together. So we're going to have our real parts and then our imaginary parts. And then we try and add them all together. So we end up with 7 plus 8 is 15. We have minus 5i plus 4i. We end up with minus 1i, which you can write down as minus I or minus 1i, whichever you feel more comfortable with. So exactly the same as if we had a situation that had x's in it, and we gathered the x's together and the constants together, added the x's, added the constants. So we're just going to gather real with real, imaginary with imaginary, and add them up as normal. So here we have our real parts and our imaginary parts. Our first number is real part and our second number is real part. But here we see we're taking stuff away. So just like if we were doing normal algebra, we're going to have to multiply out this bracket. So we're going to have 4 plus, pardon me, we're going to have 4 plus I. There's nothing multiplying that bracket, so it just works out the same. We have 1 of that bracket, but we're subtracting 1 of this bracket, so we're going to have minus 15. So we can imagine there's a minus 1 here if it makes it more comfortable for us, but we're subtracting 1 of this bracket, so we're going to be taking both of those things away. So we are going to have minus 15 is minus 15, minus 2i is the same as plus 2i. And now we can gather the real and the imaginary parts. So we have 4 and minus 15 is the real part. We have 1i and plus 2i for our imaginary part. So we have 4 minus 15 for our real parts and 1i plus 2i for our imaginary parts. So we end up with minus 11 for our real part and 3i for our imaginary part. It is very important that from the beginning we are doing this gathering together of real and gathering together of imaginary. It is important as things get more complicated. So we want to be in this habit from day one. Here we have our first number and our second number. We can see that there's actually a letter variable for our I, and we'll see how to deal with that in a minute. But first we're taking away 1 of this bracket. So we're going to take that away. And we have 6 plus ki minus 10 minus 9i. Gather together the real and the imaginary. And we get 6 minus 10 in our real plus ki minus 9 in our ki minus 9 in our imaginary. Our real parts we can just add together or subtract, and we end up with minus 4. And how would we gather these together? Well, they both have I in them, which which makes I a common factor. So I could write that as k minus 9i. So I've grouped together the real part, and I've grouped together the imaginary part as best I can because there's a letter involved. So that's as far as I could go with that addition. We'll often be told complex numbers in terms of a label because it makes it easier to write things down because the numbers are bigger onto themselves. So Z will be our first number, it's 3 minus 2i, and W is 1 in the real and 4 in the imaginary, plus 4 in the imaginary. So how would we get 5 times W? Well, we know what W is, so we just write down 5 times whatever W is. So if we get this in the exam, we have 5W means 5 multiplied by W. We know what W is, so we just write it down, and now we can multiply this out. So we have 5 times a bracket, so we have 5 of this and 5 of that. So we're going to have 5 groups of minus 1 is just 5, and 5 groups of 4i would be 20i. And that's as far as we can go. What is Z plus W? Well, I know what Z means. It is 3 minus 2i. And I put brackets around that as a general convention for subbing in to anything. And I have W is 1 plus 4i. And now I'm back to what I had in my earlier questions. So I just have 3 minus 2i plus 1 plus 4i. Gather together the real parts and the imaginary parts. And I have 3 plus 1 minus 2i plus 4i. So I end up with 4 in the real in total and 2 in the imaginary. So minus 2 plus 4 is 2 of my i's, my imaginary numbers, my square root of minus 1. So what does Z minus 3W give us? Well, I just write down what Z is and then minus 3 of W. So I end up with 3 minus 2i in brackets minus 3 of W is 1 plus 4i. So I just do my multiplying out. There's nothing on this bracket, so it's just 1 of this bracket. Oops. 1 of that bracket, and minus 3 ones, minus 3 ones, minus 3 4i's. So minus 3 ones is just minus 3, and minus 3 4i's would be minus 12i. You're just multiplying minus 3 by 4, and that's times I. The same way as we would do if we had x there. So if we had minus 3 times 4x, we do minus 3 times 4 is minus 12 times x. Now we can gather together our real and imaginary parts. So we have our real parts are 3 and minus 3. Our imaginary parts are minus 2i and minus 12i. So I gather together my real 3 minus 3, and my imaginary is minus 2i minus 12i, and I get 0 in the real and minus 14i in the imaginary. And that's as far as I can go. So that could just be written down as the complex number minus 14i, but we know that if we have that written down, it's just a shorthand for having 0 in the real and minus 14 in the imaginary. And that ability to keep track of the fact that I have a real and imaginary part to every complex number is very important. So while we could write it down as minus 14i, we must always keep that 0 in the real in the back of our minds. So for now, I'm going to leave that 0 there as an important part of that number. So we have 2z plus w. So we know what that means. 2 times 3 minus 2i plus w is up here 1 plus 4i, and we multiply out our bracket. We have 2 of this bracket, so we have 2 of each thing in the bracket. So we have 2 groups of 3 is 6, and 2 groups of minus 2i is going to be a total of minus 4i, and then we just have 1 of this bracket, so it's just plus 1 plus 4i. and we gather together our real numbers and our imaginary part. And we have 6 plus 1 in our real part and minus 4i plus 4i in our imaginary part. So we end up with a total of 7 in the real and 0 in the imaginary. So this would be a number that we've seen lots before. It would just be the normal whole number 7. And up until now, we would have just written it as 7. But when we're dealing with complex numbers, we have to keep track of the fact that we're cautious that there's a 0 in the imaginary part of that number. So again, for now, to focus on that, I'm going to keep that 0i explicitly written down so that I'm keeping track of the fact that just a real number by itself, so just the number 7 by itself, has a hidden 0i for its complex or its imaginary part. So that's what we need for adding our complex numbers. Gather the real terms together and the imaginary terms together, add them up, and that is all we do. So that is what we need for now.